Hello everyone, my name is Prakhar Dangolia, enrollment number 0801CS221109. In this video, we are going to learn what is OCR, the challenges of OCR, how can we train OCR, and also the basic introduction of Streamlit and PyPDF. And at the end of the video, we will see a code how we can use OCR and Streamlit to create a simple app. So first, what is OCR? OCR or Optical Character Recognition is the process of converting images of printed or handwritten text into machine-readable text. When you scan a document or take a picture of a piece of text, what you essentially have is an image. While human can easily read text from an image, a computer doesn't have the same ability. It only sees a collection of pixels, light and dark spots that form shapes. OCR bridges this gap by transforming those pixel-based images into something computer can interpret, search, edit, and store. It allows machines to see and read text in images, whether it is a printed page, a photo of a signature, or even handwritten data. Now let us look at the history of OCR. Let me give you a bit of historical context. OCR isn't a new technology, but it has come a long way since its early beginnings. The roots of OCR date back to the early 20th century. It was first developed as a tool to help the visually impaired read printed text by converting it into readable formats, like Braille. Over time, this technology has significantly advanced. In the 1970s, the OCR system became capable of reading more complex characters. Today, OCR is powered by advanced algorithms and machine learning, enabling it to recognize a wide variety of text formats, fonts, and even handwriting. Now, you might be thinking, how does OCR works? So it works mainly by four steps. Step 1 is image processing. The first step in the OCR process is image processing. This step is crucial because when we capture an image of the document, whether it is scanned or taken by a camera, it is often imperfect. The quality of the image might not be ideal or direct text recognition. It could have unwanted dots, is skewed, or suffered from poor resolution. To address these issues, the OCR system pre-processes the image to make it as clean and readable as possible. Some common pre-processing techniques includes noise reduction, binarization, skew correction, resizing and thresholding. Step 2 is character detecting. After pre-processing the image, the next step is character detecting. This is where the OCR system identifies which part of the image contains text. The system scans through the image and breaks it down into different components such as individual lines, words, and characters. This step is called segmentation. For example, the system may first divide the image into lines of text, then it breaks each line down into word, and each word is further divided into individual characters. Another challenge here is distinguishing between text and non-text elements in complex documents. As we might know that some documents may contain tables, text or graphs. So the OCR system needs to be able to segment these components accurately and focus only on the areas that contains text. Step 3 is text recognition. Once the text has been detected and segmented, the next step is text recognition. This is where the OCR system converts the detected shape of characters into actual letter, number and symbols. In this stage, the OCR system uses a process called pattern matching to recognize each character. It compares the shape of the character in the image with a predefined set of known characters stored in its database. For example, the system knows what the letter A or number 5 looks like, so it tries to match the shapes in the image with these templates. The text OCR use machine learning models like CNN or RNN, and these models have been trained on large datasets of different handwriting styles and can recognize subtle variations in how people write letters or numbers. Step 4 is post-processing. The final step is the post-processing, where the system refines the recognition text and corrects any errors. No OCR system is perfect, and mistakes can happen during the recognizing process. For example, the system might confuse in similar looking characters like I and 1 or 0 and O. To reduce error, the OCR system uses language models and dictionaries to predict the most likely word based on context. If the OCR mistakenly reads the word house to house where O is 0, then the model can correct it by checking against a list of valid words. Now, however, OCR is not without its challenges. One of the biggest hurdles is recognizing handwritten text. Unlike printed text, which is consistent and uniform, handwritten can vary dramatically from one person to another. Different handwritten styles, sloppy writing, or even cultural variations can make it difficult for OCR system to accurately identify that handwritten character. Also, low quality images also pose significant challenges. If the image is blurred, have shadows, or not properly scanned, then it becomes much harder for OCR to recognize the text. OCR also deals with different font size and languages. Some fonts may be stylized or decorative, make them harder to recognize, while others may be distorted, or if the document is damaged or scanning is incorrect, then OCR is unable to detect those words and numbers. Now we will study how to train OCR, but before that we need to know why is it needed to train OCR. From the challenges that we have studied in OCR, we have understood some basic things like the pre-trained OCR model like Tesseract works well for standard printed text, but they may struggle with unique fonts, handwritten text, or low quality images. Also, the real-world images often contains noise, distortion, low lighting. Also, the text in real-world applications varies in font size, space, and layouts. For instance, the text on the business card might be laid out very differently from the text on a form. So, by training the OCR model, we can ensure that it correctly understands and interprets the text regardless of its arrangement or structure. Now, there are mainly 6 steps how we can train the OCR. The first step is understand OCR. First, let's begin by understanding how does OCR works. At its core, an OCR system processes an image, detects characters, and then recognizes and translates other characters into machine-readable text. Step 2 is setting up the environment. To get started, we need a few key libraries in Python like OpenCV, Tesseract, PyTesseract, TensorFlow, or PyTorch, etc. Step 3 is pre-processing the data. Before feeding images to the OCR model, we need to pre-process them. Here is how. First is grayscale conversion. That is converting the image to grayscale removes unnecessary color details and focuses on the structure of the text. Second is thresholding and binarization. That is thresholding techniques like Ohtsu's method converts the image into binary format for better readability. The third is noise removal. Filters like Gaussian blur can help reduce noise, which is crucial when working with images containing handwritten or printed text. Step 4 is training the OCR model. Now, to actually train an OCR model, we have generally two options. The first is fine-tuning an existing OCR model with Tesseract. That is, we can fine-tune Tesseract for our specific dataset if we need it to recognize specific fonts or handwritten characters. This involves training it with labeled dataset of images and their corresponding text. And the second option is building a custom OCR model with machine learning. If we need more control over the OCR model, then we can train a neural network from scratch. That is, we have to create a dataset collection model architecture, like we can use CNN, RNN hybrid architecture for sequence-based text recognition, and this type of model extracts the features using a convolutional layer and uses a recurrent layer for subsequent modeling. Also, we can do training the model, that is, train the model using supervised learning. We can use framework like TensorFlow or PyTorch to build and train the model on labeled data. Now, step 5 is post-processing and evaluation. Once the model is trained, the next step is post-processing the OCR output. The model may make some mistakes, so we need to apply corrections or filters like spell checkers or grammar rules to improve the accuracy of the extracted text. Step 6, that is the final step, is deploying the OCR system. Once the OCR system is trained, it is time to deploy it. We can integrate it with the Python web application using frameworks like Flask or as a desktop app using Tinkler. This model can be deployed on cloud platforms to be used by other applications. PyPDF is an open source Python library that allows users to work with PDF files programmatically. It provides functionalities to read, write, and manipulate PDF documents, making it easier to manage the structure and content of these files. The library is particularly useful for developers who need to automate the processing of PDF documents, extract information, or create new PDFs based on existing data. Originally, it is known as PyPDF2. It has since evolved, gained additional features and improvements, and it is commonly referred to simply as PyPDF. It is lightweighted and easy to use, making it suitable for various applications. The key features of PyPDF are reading PDF content, extracting text, merging PDF files. These features is beneficial when compiling reports, combining invoices, or creating comprehensive documents for various sources. With just a few lines of code, you can easily merge several PDFs into one cohesive document. We can also split the PDF files, rotate the pages, and add watermarks and annotations. Streamlit is an open source Python library used by building interactive web applications for data science, machine learning, and various other domains. It simplifies the process of turning data scripts and machine learning models into shareable web applications with minimal effort and coding. Streamlit allows users to create beautiful, responsive, and interactive dashboards directly from Python scripts, focusing on simplicity and speed for rapid prototype. It's designed to make app building accessible for data scientists and developers who may not have a background in web application. There are several advantages of using Streamlit. The first advantage is simplicity. Streamlit allows you to write web applications using simple Python scripts without needing to learn front-end technologies like HTML, CSS, or JavaScript. You can convert a Python script into a web app by running it in Streamlit with very minimal additional code. It works through widgets that are built directly into the Python script, allowing the user to create interactive interfaces for data visualization, ML model testing, and more. The second advantage is real-time interactivity. With Streamlit, you can build apps that allow users to interact with the data in real time. The library provides widgets such as sliders, buttons, text inputs, file uploaders, and more, which can be used to let users dynamically interact with data visualizations, models, or other functionalities. Streamlit also automatically reruns your app, which users interact with widgets, ensuring real-time updates without requiring manual reloads. The third advantage is integration with machine learning. Streamlit is particularly useful for building applications that interact with machine learning models. You can create an interactive interface to test different models, adjust hyperparameters, input sample data, and see model predictions or evaluation metrics in real time. It is compatible with popular libraries like TensorFlow, PyTorch, and Keras, making it easy to deploy models for demonstration of testing purposes. The fourth advantage is zero configuration. You don't need to worry about configuring the server or managing backend components. Once your Python script is written, you can simply run it using Streamlit run your script.py, and Streamlit automatically handles the setup of the web server, routing, and rendering. The another advantage is rapid prototype. Streamlit is excellent for quickly building prototypes for data exploration or machine learning. You can create a working version of your application in a matter of minutes or hours, testing it with the real users and iterates based on feedbacks without worrying about complex deployment or infrastructure. Another advantage of using Streamlit is open source. Streamlit is open source, which means it's free to use and has an active and growing community of developers and contributors. There are plenty of tutorials, forums, and community developed apps that can help beginners get started quickly. There are several disadvantages of using Streamlit too. The very first disadvantage is limited customization. It is more suited for rapid prototype and internal tools and less for building full customized production grade web apps. The second is reactive nature. Since the app reruns on every interaction, it may not be as efficient for apps that needs to handle large datasets or complex computations without proper caching. Also, Streamlit is primarily geared towards data-focused apps and dashboards, so it's not ideal for more complex web applications that need custom routing, complex user interactions, or persistent databases. So far, we have studied about what is OCR, how can we train OCR, also about what is PDF and Streamlit, what are the advantages and disadvantages of using Streamlit. Now, practically, we are implementing the code of how can we run our code in Streamlit. First, for that, we have to create a code. So, this is a code of the project where this is a PDF file containing student name, enrollment number, and marks. And from that PDF file, we have to extract the marks in such a way that we have to create three Excel sheets from this PDF file. The first Excel sheet would contain the data of students who have the marks greater than 22, while the second Excel sheet would contain the marks and details of the students with the marks less than 22, and the third list would contain the data of student who have marks absent A, that is, they are absent in that examination. So let's try to understand this code. The Pandas PD is a powerful library for data manipulation and analysis used for working with data frames like table structures. The PyPDF2 is a library used to read and extract the text from the PDF files. The RE is the Python's regular expression module used to search for patterns in text. The PyTesseract is an OCR, that is Optical Character Recognition tool, that allows extraction of text from images. The PIL image is a module from the Python imaging library used for image processing. The PDF to image is used to convert PDF pages into image formats. This math contains the mathematical functions. Here it is used for rounding the numbers. The Streamlit is a framework to create web apps in Python, used here to build the user interface. The first function is to extract the text from PDF. So this function extracts the text from PDF file. The PDF reader Python PDF underscore path initializes the reader object for the PDF, and this full text is a variable to store all the extracted text. The loop goes through each page of the PDF, extracts the text, and appends it to full text. The text is returned at the end of the function. The second function is to extract the text using OCR. First, it converts the PDF pages to images and then uses OCR to extract the text from those images. This is used to convert each page of PDF into an image, and the loop processes each image using pytesseract.image to a string to extract this text. The extracted text is accumulated in full text and returns. Now this function is used to generate the extracted data from the text using regex, that is regular expression. This is the initialization, and it initializes an empty list to store the extracted data. The regex pattern that you see here, that is this, looks for a student record with enrollment number starting with 0801, names and marks or status. This 801 and this that you see here is showing that the enrollment number should start with 0801, and similarly this shows the student pattern, and this matches the decimal numbers marks A, none or absent, and this matches equals to pattern dot find all text is used to match find all the matches based on the regular expression patterns. The loop that you see here is the loop through matches. The match 0 is the enrollment number, match 1 is the student's name, match 2 is marks or status. If not present, set to none. If the marks or status is a number, that is round up using math.ceiling. That is, this math.ceiling is used to round up the numbers. And if the status is A, that is absent, or none, then marks are set to none. Else, the status is unknown. The enrollment number, name, marks, and status are appended to the data list using this. And finally, the data list is returned. This function is used to process the data, and it converts the data list into the pandas data frame with columns like enrollment number, name, marks, and status. This df.drop_na is used to remove the rows whether either enrollment number or name is missing, and the data frame is printed for debugging processes. Now this df.loc, this updates the status based on the value of marks. That is, if the marks is greater than or equals to 22, the status is pass. If marks are less than 22, then the status is fail. And this is used to fill any remaining empty statuses with absent. The function then creates three separate data frames: passed, fail, and absent, based on the student's status. Finally, that this is a code line, that is, finally it returns these three data frames. Now we would see the function to generate the Excel sheets. This function generates an Excel file with three sheets: passed student, failed student, and absent student. This pd.excelwrite that you see here, pd.excelwrite, is used to open a context to write multiple data frames to one Excel file. It checks if each data frame, that is passed, failed, or absent, is non-empty and writes it to a specific sheet in the Excel file. This Excel file is saved as student_marks.xls. Now, this is the main Streamlit application that you see here, and this is the code of the main function. The st.title is used to set the title for a Streamlit web application. In this case, the title displays that the student marks extraction from PDF should be written at the top of the page. And this st.file uploader is which allows the user to upload a PDF file to the app. The message upload a PDF file contains student marks that is shown to the user as prompt. The parameter, that is type, is used to ensure that only PDF files can be uploaded. And the PDF underscore file, this variable will hold the uploaded PDF file. If no file is uploaded, then it will be none. If PDF underscore file, that means this checks if a file has been uploaded by the user. If no, the file is uploaded. This block is skipped. With open upload file.pdf, this opens a file called uploaded file.pdf in write binary mode. That is WBS write binary mode. This uploads the file, and this states that the uploaded file is temporarily saved as uploaded file.pdf on the server where the app is running. This pdf.file get buffer gets the binary content of the uploaded file, and this app.write is the binary content of the uploaded file is written to the uploaded file.pdf. Now, the extracting the text from the PDF. This extracting the text from the PDF. This calls the function, that is this, with the parameter of the uploaded file, and the function attempts to extract the text from the PDF using PyPDF2. The extracted text is stored in the variable text. Handling no text extractions. If not dot text, this line means that this checks if the extracted text is empty or consists only of white spaces. If true, it means no text was successfully extracted. And st warning displays a warning message to the user. No text extracted from PDF attempting OCR. This is the message that it will show if the data is not extracted properly. And this extract underscore text underscore using OCR is this that checks if the PyPDF would not extract any text. The app falls back to OCR to extract the text from the images to the PDF page. The text extracted via OCR is then stored in text. Now handling no data extractions. If not text.strip, then this checks again if the text is empty after attempting OCR. And st.error, that is if no text was extracted even after OCR, an error message is shown to the user. No data extracted. Please check the PDF format. And return, that means this stops further execution of the main function if no data was extracted from the PDF. Extract data using regex. This extract data from text. This function is called to extract the structured data, that is enrollment number, name and marks, from the extracted text using regular expression. The structured, that is data. The structured data is stored in the data variable, which contains tuples of enrollment number, student names and their marks and status, and display structured data from debugging. This is the next line of codes. This st.write displays the extracted data on the Streamlit app for debugging or verification purpose. It shows the row extracted data as a list of tuples. Now the second lines are processing data, that is pass, fail, absent or categorizes. The process, okay, the process data that you see here. This function processes the extracted data and categorizes a student based on their marks. That is passed if the student contains the marks greater than or equal to 22, failed if the student secured the marks less than 22, and absent if the student contains marked as absent or with the missing marks. And then the next line of codes are about print data frames for debugging. The st.subheading, that means it creates a subheading in the app labeling each category of the student, that is passed, failed or absent. And st.write is used to display the data frame containing student data for each category below the respective subheadings. Now this pd.concate combines the three data frames, that is passed, failed and absent, into a single data frame, ignoring the original index. This len function counts the total number of students across all the categories, and this total number of students is stored in the variable in this. And now after that we can generate the Excel files and provide the download link using this line of codes. Now so far we have understood this code, and now we will see how we can create an app of this code using the Streamlit. So first we have to go to GitHub, and here we have to create a new repository. So I am creating a repository with Prakhar /project. Okay, so it will be public and create repository. Now here we have to upload the files. So I will choose the files, and here I will choose two files, that is first the code of the app, and second is the requirements.txt. I will open both, that is two files, and then will do the commit changes. Now we have to open Streamlit website. If you do not have created account here, so you first have to create the account. But since I have created the account, so I can directly sign in. Now here we have to create an app. So click here, and yes, I have an app. And here we have to give the repository link. So here we would paste the GitHub link, GitHub URL, and the branch is main. Okay, so our file name was app.py. So here we will do app.py, and this will be the link through which we can access the app. So we can give any name to this link, like Prakhar project 2024. Okay, now we can just click on deploy, and we have to wait. We have to wait till this icon shows, and when we click on manage app, we can see all the files and all the libraries that are being installing. So now here it is, our app is ready, and this is the link through which we can access our app. And here when we click, we can see that this is showing our GitHub repository where our code is present. Thus we do not need any extra database. When we upload a file here, the code that is running in the backend is stored in GitHub, and from here browse file. First let us change its background color. So first you have to click on the three lines, then settings, and then in this dark mode you have to go to light, and then okay. Now the background color is white. Now when you click on the browse files, then you can take any file, that is this file actually contains the serial number, enrollment number, name and marks. And when I uploaded this file, we can see that the passed student, failed student and absent student data are generated. Now in the last, we have given an option to download this Excel file. When we click on this download Excel file, we clearly see that the Excel file is downloaded. That is, these 10 students have passed the exam, these 14 students failed the exam, and these 3 students were absent. So this is how we created a basic Streamlit app. Thank you everyone.